Okay, so good day everyone. So today we will be discussing applications of DE on electrical circuits. So the application of DE in electrical circuit is mostly specific on inductance and capacitance only. So let's start with your RL circuit. Okay. So when you say RL circuit, it is a circuit consists of a resistor, okay, which is this one, and your inductor, okay, which is this one. Okay. So this is your resistor and this is your inductor. Okay. So your resistor, let's have a little recap of what a resistor is. So a resistor is an electrical component designed specifically to provide a fixed amount of resistance. Okay. So it means the measure of resistance is what we call your unit in ohms. Okay. Meanwhile, our inductor, no, is a coil of wire, just like this one, that stores energy in a magnetic field. Okay, so it stores energy. So the unit for our inductance is in henries. Okay, take note, it is in henries. And we have here our electromotive force or our voltage source. Take note, your EMF or the electromotive force is also called the voltage source, which is measured in volts. Okay, this is our voltage source. This is measured in volts. Okay, so take note, your I represents your current. Your R represents your resistance in our differential equation there. Your L represents your inductance. And your E represents your electromotive force. Take note that our variable only is I and T. So it means the rest of this, your R, your L, your E, and your L are all constants. Okay, so later on, it will be like a linear differential equation. Okay, so let's try one problem with this one. An RL circuit has a resistance of 10 ohms, an inductance of 1.5 henries, and applied EMF of 9 volts. It has an initial current of 6 amperes. Okay, so we have here given the resistance is 10 ohms, the inductance is 1.5 henries, the EMF is 9 volts, and the current of 6 amperes, initial current. When you see initial current, at time equals 0, the current is 6 amperes. So we need to find the current in the circuit at any time. Okay? Okay, so with our formula, that would be DI. Okay? That would be DI over dt plus R over Li equals E over L. Okay, that is our formula for your RL circuit. When you see RL circuit, resistor inductor circuit. So let's substitute di over dt plus your resistor is 10 over inductor is 1.5 henries I equals E, which is 9 volts over 1.5 henries. So what would be your 10 over 1.5? That would be 20 over 3. Let's just use that. That would be 20 over 3i. And what would be your 9 over 1.5? That would be 6. So it means this is a linear equation which is linear to I. We will need to find our P of T and our Q of T. So our P of t here is syempre the one that has only I raised to 1. That would be 20 over 3. Our Q of t would be 6. And our integrating factor would be E raised to 20 over 3 dt, which is equal to E raised to 20 over 3 t. So now we have our general solution. Okay. That would be the dependent variable multiplied by the integrating factor equals integral of the integrating factor multiplied by your Q, which is 6 dt plus C. Okay? So what would be the integral of e raised to 20 over 3? So again, let us let our u to be 20 over 3t and your du would be 20 over 3 dt. And eventually, 3 over 20 du would be equal to dt. Okay? So that would be I e raised to 20 over 3 t equals, okay, let's have this one, e raised to 20 over 3t, that would be e raised to u now. Then 6 multiplied to 3 over 20 du. So the result would be I e raised to 20 over 3t equals, okay, 6 times 3 over 20. What would that be? That would be 9 over 10. So 9 over 10 e raised to u, which is 20 over 3t plus c. And your I would be equal to, okay, that would be 9 over 10 because we will multiply the whole equation by e raised to negative 20 over 3t plus c, e raised to negative 20 over 3t. But we need to find the value of c. So the value of c, we can get that from our initial condition. So at time equals 0, current is 6 amperes. So substitute 6 equals 9 over 10 plus c e raised to negative 20 over 3 times 0, which is 1. So it means the value of c is 6 equals 9 over 10 plus c. That would be 5.1 or 51 over 10. So it means our answer for A, which is the current in the circuit at any time, would be I equals 9 over 10 minus 51 over 10 e raised to negative 20 over 3 t. That is the current at any time. So the current after 3 seconds. No? So after 3 seconds, that would be, just substitute 3 to our equation. That would be 9 over 10 minus 51 over 10 times e raised to negative 20 over 3 t, which is how many seconds? 3 seconds. So our answer is 0.9 amperes. That is our answer. You just substitute time equals 3 seconds. Okay. Next. Next, we have our RC circuit. So when you see RC circuit, it is now a circuit. Okay, so take note. This is now capacitance. So your RC circuit, okay, is now composed of a resistor and a capacitor. So again, uh, a capacitor usually has the ability to store electric charge. by using two conductive plates. Okay, so it has the same purpose as that of inductance or inductor, but it only what you call that stores energy by using two plates, okay, conductive plates. So the measure of capacitance is what we call the measure of a capacitor is your capacitance, which is the units is in farads. Okay. We have no inductance in the circuit. And take note, the equation governing the amount of electrical charge on the capacitor. Okay. So take note, nakapartner ang capacitor into your charge. So in this differential equation, okay, our dependent variable is the charge. When you say charge, that is the amount of electrons contained in your electrical circuit. So the measure of that is in coulombs. And later on, if you convert that one into your electric current in amperes, it is just the first derivative of the equation of the charge. Okay, so let's have that in our problem. A circuit has an EMF, okay, that is the voltage, so E is 100. A resistance of 5 ohms, so R is 5. Capacitance of 0.02 farad, okay, and an initial charge on the capacitor of 5 coulombs. Okay, initial charge. When you say initial charge, that is at time equals 0, the Q is 5 coulombs. Okay, we get the expression for the charge at any time. So first, we need to get the expression of the charge. That would be dq over dt plus 1 over RCQ equals E over C. Let's check. E over R rather. So let's just substitute. Okay, you have dq over dt plus 1 over your resistance is 5. Multiply that to 0.02. Q equals E, which is 100 divided by 5. So simplify that one. What is 1 over 5 times 0.02? That would be 10. So it means our equation is dq over dt plus 10q is equal to 100 over 5, that is 20. So it means our P of t is 10, our Q of t is 20. And our integrating factor, that would be E raised to 10 dt, which is equal to E raised to 10t. Then let's now have our general solution. That would be Q multiplied to your integrating factor equals integral of the integrating factor multiplied to your Q, which is 20 dt plus C. Okay, if we let U equals 10t, it means du is 10 dt. And eventually, 1 over 10 du is equal to dt. So that would be q e raised to 10t equals integral of e raised to u multiplied to 20 times 1 over 10 du plus c. And that would be q e raised to 10t equals, okay, 20 over 10, that is 2 e raised to 10t plus c. Okay? And if we multiply e raised to negative 10t on the whole equation, that would be q equals 2 plus c e raised to 10t. But we need to find the value of c. At time equals 0, your q is 5. So substitute that. 5 equals 2 plus c e raised to negative 10t, which is 0, because your time is 0. Rather 1. Okay, this is 0. So this is 1. So c is 3. So if C is 3, it means our answer for A, that would be Q, equals 2 plus 3 e raised to negative 10t. That is our answer for letter A. That is the expression of the charge at any time. How about the current in the circuit at any time? Okay. So the current, which is I, that is just the first derivative of Q. So what would be the derivative of this one? That would be 0 plus 3 times e raised to 10t multiplied to negative 10. So it means your I would be negative 30 e raised to negative 10t. That is our answer. Okay? So that is all. So thank you so much for listening and God bless.